In the hierarchy of military hardware appreciation, there is a distinct and often fatal prejudice that favors the loud and the lethal over the heavy and the essential. We spend endless hours analyzing the penetration statistics of sabot rounds or the radar cross-section of fifth-generation fighters. Yet we frequently ignore the vast churning diesel engines that actually allow those systems to exist in the field. But if you look at the grim reality of modern near-peer conflict, specifically the lessons learned from the blackened highways of Eastern Europe, you realize that the tank is not the primary target anymore. The fuel tanker is. This shift in the geometry of warfare has created a massive, terrifying crisis for the United States Army, a force that has built its entire logistical doctrine on the back of a vehicle that was designed when disco was still topping the charts. The backbone of American logistics, the Heavy Expanded Mobility Tactical Truck, or HEMTT TM977, and the Palletized Load System, the PLSM-1075, are legendary machines, but they are tired, they are conceptually outdated, and in a world of drone swarms and precision artillery, they are soft targets. Enter the Challenger, a machine that looks less like a truck and more like a rolling fortress, designed by someone who expects the apocalypse to arrive on a Tuesday schedule. We are talking about the Rheinmetall HX3 8x8, specifically the prototype configuration currently undergoing brutal evaluation to potentially replace the entire heavy tactical fleet of the United States Army. This is not just a new model year refresh. This is a fundamental reimagining of what a military truck is supposed to be. It is an attempt to fuse the raw, mud-churning capability of a dedicated off-roader with the survivability of an armored personnel carrier and the brain of an autonomous robot. The central conflict of this machine is fascinating because it tries to answer a nearly impossible question. Can you build a logistics vehicle that is sophisticated enough to drive itself and survive a mine blast, yet reliable enough to be fixed with a hammer in a swamp? The stakes here are incredibly high because the United States Army is currently running the Common Tactical Truck Program, a massive acquisition effort intended to replace roughly 5,700 heavy trucks. The winner of this contract will define the logistical tempo of NATO forces for the next half-century. Rheinmetall, in a strategic partnership with GM Defense, has put forward the HX3 as the answer, betting that the future belongs to integrated armor and digital backbones rather than bolted-on protection and mechanical linkages. But as we peel back the layers of this steel giant, we have to ask if the pursuit of high-technology perfection has created a system too complex for the chaotic, dirty reality of war, or if this level of sophistication is the only way to keep supply lines open when the enemy is watching every road from the sky. If detailed technical breakdowns of military design and strategy interest you, subscribe. I have got more of these coming. To understand why the HX3 exists, you first have to understand the lineage from which it was born, because this truck is the latest evolutionary step of the legendary MAN Cat-1, a vehicle that redefined off-road mobility in the 1970s. The HX3 retains the core DNA of that lineage, built around a chassis concept that is fundamentally different from commercial trucks converted for military use. Most military trucks start as commercial heavy haulers that get painted green and given a lift kit, but the HX series is purpose-built military hardware from the frame rails up. The foundation of the HX3 8x8 is a torsion-resistant ladder frame that is designed to be incredibly stiff, forcing the suspension to do the work rather than allowing the frame to flex. This is a critical design choice because it provides a stable platform for the load handling systems and, more importantly, for the mounting of heavy weaponry or complex sensor suites that cannot tolerate the twisting forces of cross-country travel. The suspension system on the HX3 represents one of the most significant leaps forward in heavy trucking technology, moving away from purely mechanical solutions to active systems. while the base models can be fitted with parabolic leaf springs, which offer extreme durability and simplicity. The high-performance variants contending for the American contract feature a hydropneumatic suspension system on the rear axles. This is not just about driver comfort, although reducing fatigue for a crew driving 12 hours a day is a tactical factor. It is about load stability and firing platforms. This hydropneumatic setup allows the vehicle to change its ride height, lock out the suspension for crane operations or artillery firing, and actively dampen the violent oscillations that occur when a 40-ton vehicle hits a ditch at 60 kilometers per hour. The result is a vehicle that can traverse terrain that would snap the axles of a standard commercial truck, maintaining traction by keeping all 8 wheels firmly pressed into the dirt regardless of the articulation required. Powering this behemoth is the MAN D26 series engine, a 6-cylinder inline diesel that is a masterpiece of modern industrial engineering. This power plant generates up to 540 horsepower and, more importantly, delivers a crushing 1,844 pound-feet of torque. However, the raw numbers only tell half the story because military engines live in a different world than their civilian counterparts. The engine in the HX3 is designed to operate on F-34 NATO standard fuel, but it is also capable of running on degraded fuels or high-sulfur diesel found in austere environments, thanks to a robust fuel filtration and management system. It meets Euro 6 emission standards, which is a requirement for peacetime operations in Europe, but it can be stripped of its emission-limiting software constraints in combat scenarios where survival takes precedence over environmental compliance. This engine is coupled to a ZF EcoLife 7-speed automatic transmission with a torque converter, a critical feature that smooths out the power delivery and prevents stall-outs during critical low-speed maneuvers in deep mud or sand. But mobility is only the price of entry. The defining feature of the HX3 is its obsession with crew survivability, specifically through the design of the Integrated Armor Cabin, or IAC. In previous generations like the HEMTT TM977 or the older MAN trucks, armor was often an afterthought, a heavy kit bolted onto the skin of the vehicle which added weight, stressed the door hinges, and ruined the center of gravity. The HX3 flips this paradigm by designing the cabin as an armored citadel from the drawing board. The IAC is a monocoque safety cell constructed from high-hardness steel and advanced composites that offers protection levels comparable to dedicated armored fighting vehicles. It is decoupled from the chassis via a specialized mounting system that isolates the crew from the violent shocks of the terrain and, crucially, from the energy of a mine blast detonating under the wheels. The floor of the cabin is arguably the most engineered component of the entire crew compartment. It utilizes a floating floor concept that is mechanically separated from the hull bottom, ensuring that the deformation of the hull during an explosion does not transfer kinetic energy directly into the legs and spines of the occupants. The seats are blast attenuating, suspended from the roof or sides rather than mounted to the floor, further mitigating the lethal vertical acceleration of an underbelly IED. The glass is essentially transparent armor blocks capable of stopping multiple hits from heavy machine gun fire, and the entire cabin is sealed for nuclear, biological, and chemical protection, creating an overpressure environment that allows the crew to operate without masks even in a contaminated zone. This is a level of integration that makes the hillbilly armor days of the early Iraq War look like ancient history. However, the addition of this massive armored cabin introduces a severe penalty in terms of weight, and this is where the engineering trade-offs become painful. To carry the weight of the protection without sacrificing payload, Rheinmetall had to push the front axle ratings to 11 tons each, a staggering figure for steerable axles. This required a complete redesign of the steering geometry and the implementation of the Rheinmetall Command Drive, or RCD, steering system. This system allows for precise control of the heavy front end and includes a rear axle steering capability on the fourth axle. This rear steering is vital because an 8x8 truck with a long wheelbase has a turning radius comparable to an aircraft carrier. By actively steering the rear wheels counter to the front at low speeds, the HX3 achieves a turning circle that is surprisingly tight, allowing it to navigate the narrow, debris-choked streets of urban combat zones where a 3-point turn is a death sentence. The technological ambition of the HX3 reaches its peak with the integration of the Automated Load Handling System, or ALHS. For decades, the operation of the palletized load system M1075 involved a giant hook arm that would grab a flat rack and pull it onto the truck. It was a good system, but it required the driver to line up perfectly and often required a crew member to get out and guide the hook or secure chains, exposing them to enemy fire. The ALHS on the HX3 changes the game by automating the entire process. Using a combination of laser sensors and cameras, the truck can identify the flat rack, align the lifting mechanism, and pull the load aboard without the crew ever leaving the protection of the armored cabin. This system can even load containers that are not perfectly aligned with the truck, using an articulating arm that reaches out and corrects the geometry. This capability transforms the logistics mission from a manual labor task into a push-button operation, drastically reducing the time a convoy spends stationary at a drop point, which is statistically the most dangerous time for any supply run. Yet, as we admire the robotics, we encounter the hidden cost of this digital revolution, the reliance on the digital backbone. The HX3 is built around the NATO Generic Vehicle Architecture, or NGVA. This is an open architecture electronic standard that allows all the systems, cameras, engine management, defensive aids, radios, to talk to each other on a high-speed data bus. It enables features like the transparent cockpit, where cameras stitched together provide a 360-degree view through the armor, displayed on screens inside the cab. It also enables the leader-follower autonomy capability, where a single-manned truck can lead a convoy of unmanned HX3 trucks that follow electronically, like ducklings behind their mother. This solves the chronic shortage of military truck drivers, effectively multiplying the logistical throughput without needing more humans. But it also turns the truck into a rolling computer network. Knowing what you now know about its performance in the field, do you think the design trade-offs were worth it? Share your thoughts below. This brings us to the operational reality and the comparison with the incumbent, the Oshkosh HEMTT-A4. The HEMTT is an icon. It has served the U.S. Army since the early 1980s, and the current A4 variant is a rugged, powerful beast. But structurally, the HEMTT shows its age. Its suspension is stiffer, transferring more shock to the crew and the cargo. Its cabin, while now armored in the A4 long-term armor strategy configuration, feels cramped and utilitarian compared to the ergonomic, screen-filled cockpit of the HX3. The HEMTT is dumb iron. It works because it is simple and heavy. You can fix a lot of its problems with a wrench and a sledgehammer. The HX3, by contrast, is a system that might require a laptop and a diagnostic software key to clear a fault code before the parking brake releases. Imagine a scenario in a muddy forward operating base in Eastern Europe. It is raining, the temperature is near freezing, and the maintenance crew has been working for 30 hours straight. Oshkosh HEMTT TM985 blows a hydraulic hose. The mechanics curse, crawl underneath, splice a new line, refill the fluid, and the truck rolls out. Now imagine the HX3 in the same mud pit. It throws a sensor error on the active suspension system because a clump of clay has obscured a ride height laser. The truck's computer, trying to protect the chassis, limits the top speed to 10 kilometers per hour in limp mode. The mechanics have to wash the sensor, reset the electronic control unit, and hope the NGVA bus reshakes hands with the suspension controller. The capability of the HX3 is vastly superior when it works, but the friction of maintaining such a complex machine in the field is a genuine concern that veteran maintainers lose sleep over. However, Rheinmetall has anticipated this criticism. They argue that the diagnostic systems are actually a boon, telling the mechanic exactly what is wrong rather than forcing them to guess. They also point to the emergency running mode, a hardwired override that allows the driver to bypass almost all safety interlocks and sensor inputs to get the truck moving in a combat emergency. If the engine is overheating, or the transmission fluid is low, or the suspension is collapsed, the driver can smash the emergency button and the truck will sacrifice itself to get the crew home, running until the engine literally seizes. This is a crucial acknowledgement that in war, equipment is expendable, but crews are not. The operational comparison also highlights the modularity difference. The HX3 is designed with the universal torsion-resistant subframe, which acts as an interface adapter. This means you can swap mission modules, fuel tankers, cargo bodies, radar systems, or even the newly developed artillery truck interface, much faster than on legacy platforms. There is a version of the HX3, the 10x10 variant, that mounts a fully automated 155mm howitzer turret, effectively turning the logistics truck into a mobile artillery piece. While the U.S. Army is primarily looking at the 8x8 cargo variants, this modularity is seductive. It suggests a future where the distinction between a logistics truck and a combat vehicle blurs. If your supply truck can mount a remote weapon station with a 30mm cannon and an active protection system to shoot down incoming anti-tank missiles, is it still just a truck? The off-road performance comparison is stark. The HEMTT TA4 is excellent, but the HX3 is uncanny. During trials, the active suspension of the HX3 allowed it to maintain higher speeds over washboard terrain that would have shaken the fillings out of a HEMTT driver's teeth. This speed is tactical. The faster a convoy moves, the harder it is to target with indirect fire. The ability to cross a muddy ravine without slowing down to a crawl reduces the engagement window for an enemy ambush team. The rear axle steering allows the HX3 to snake through dense forests where the HEMTT would get hung up on trees. But again, this capability relies on hydraulic complexity. The HEMTT's rigid beam axles are primitive, but they are nearly indestructible. If you bend a control arm on the HX3's complex independent suspension, you are immobile. If you dent a leaf spring on a HEMTT, you keep driving. We must also consider the Made in America factor. The HEMTT is built in Oshkosh, Wisconsin, a fact that carries immense political weight. The HX3 is a German design. To overcome this, Rheinmetall partnered with GM Defense to offer the HX3 CTT, an Americanized version. This partnership is not just a branding exercise, it involves leveraging GM's massive commercial supply chain for parts and components, potentially lowering the cost and increasing the availability of spares. The pitch is that GM Defense can build these trucks in the USA, using American steel and American labor, satisfying the political requirements while delivering German engineering. It is a powerful alliance aiming to break Oshkosh's 40-year monopoly on heavy Army trucks. The driver's experience in the HX3 is fundamentally different. In a HEMTT, the driver is a laborer, wrestling with a massive steering wheel, shouting over the roar of the engine, physically exhausted after a mission. In the HX3, the driver is a systems operator. The cabin is sound insulated to the point where you can have a conversation at normal volume. The climate control actually works. The steering is light and precise. The screens display navigation, threat data, and vehicle health. This human-centric design is not about luxury, it is about cognitive load. A less fatigued driver is a more alert driver, one who is more likely to spot the disturbed earth of a roadside bomb or the glint of an optic in the tree line. In the era of the all-volunteer force, where recruitment is a challenge, offering a workspace that doesn't actively destroy the soldier's body is a significant retention tool. But the most chilling aspect of the operational reality is the electronic warfare environment. The HX3 relies on GPS for its navigation and autonomy features. We know from Ukraine that Russian jamming systems can render GPS useless across vast frontages. If the leader-follower autonomy fails because the signal is jammed, does the Army have enough human drivers to man every truck? Rheinmetall claims the HX3 has visual navigation backups, using cameras to track landmarks and road features, independent of satellite links. This visual odometry is cutting-edge tech, but it is unproven at the scale of a major war. The HEMTT requires a map and a compass. It is immune to jamming because it has no brain to jam. The shift to the HX3 is a bet that we can win the electromagnetic spectrum battle, or at least harden our systems enough to operate within it. There is also the question of the artillery truck interface, or ATI. While the primary focus here is the logistics variant, the existence of the artillery module for the HX3 platform shows the Lego set philosophy. The idea is that a single chassis type can support the entire division, hauling ammo in the morning, fueling tanks at noon, and firing 155mm shells in the evening, if equipped with the howitzer module. This creates a logistical singularity where spare parts are universal. You don't need parts for a howitzer chassis and separate parts for a truck chassis. They are the same truck. This commonality is the holy grail of military maintenance, theoretically reducing the logistical tail by massive margins. As we reach the assessment of this mechanical titan, we have to resolve the central conflict. Is the HX3 too smart for its own good? The answer lies in the changing nature of the threat. The dumb iron approach worked when we had total air supremacy and secure rear areas. Those days are gone. The rear area is now the front line. Logistics convoys are now high-priority targets for loitering munitions and long-range fires. In this environment, a truck that cannot protect its crew, cannot move fast over broken ground, and cannot integrate with the digital battle network is a liability, no matter how reliable its leaf springs are. The Rheinmetall HX3 represents a necessary, albeit expensive and complex evolution. It acknowledges that the era of the soft skin truck is over. The integrated armor cabin is not a luxury. It is a baseline requirement for survival. The autonomy is not a gimmick. It is the only way to sustain the massive supplies required for high-intensity combat when manpower is scarce. The partnership with GM Defense suggests that the U.S. Army is taking this shift seriously, looking outside its traditional suppliers to find a solution that bridges the gap between commercial automotive innovation and military ruggedness. The legacy of the HX3, if adopted, will be the death of the logistics are secondary mindset. It elevates the supply truck to the same technological tier as the combat vehicles it supports. It forces the Army to train its mechanics to be computer technicians. It forces commanders to trust algorithms to drive convoys. It is a terrifying leap of faith into the digital unknown, but looking at the alternatives, burning convoys of undefended, obsolete trucks, it is a leap the Army has to make. The HX3 is not perfect. It will have teething issues, it will frustrate mechanics with phantom sensor faults, and it will cost a fortune. But it is a war machine built for the 21st century, designed to fight its way to the front lines rather than just drive there. And in the wars to come, that distinction will make all the difference between a unit that is resupplied and fighting, and a unit that is starved and defeated. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.